This third part of the video, we are going to provide the implementation to the bind method. So in the last video, what we did was we provided the implementation to the return method. And in this case, again, just to recap, what we did earlier was to have list tm and an instance of the monads type class. And in the process, you're trying to provide the implementation to the return method and to the bind method. So here is the implementation to the return method, and what we did was we made a slide just to make things a little bit clear. The type signature for the return method as something that takes in a value of type A and giving you back a value of type MA. We just rewrote that. Where we're replacing every single M, this lowercase m in the monads type class, by something which is list t of m. And this was a type signature for the return method. And now let's do the same for the bind method. So the type signature for the bind method, I'm just going to rewrite it over here. The type signature for the bind method is something that it takes in a monadic value. It takes in a monadic value as the first parameter, and then the second parameter is basically a function that goes from a to another monadic value of mb, and finally the output of the bind method is a monadic value mb. Now again, I'm just going to replace every single m here with list tm, because list tm is acting as an instance of the monads type class. So with I'm just going to replace these m's over here with a list t of m a, and the second parameter is a function that goes from a to m b, where m again is a list t m b, and then finally the output here is list t m b. Okay, so this is the type signature for the bind method. Let's provide the implementation here. So that's the first implementation of return method, and now to the bind method. The bind method, let's just provide the implementation of the bind method. So let's have the first parameter. Let's have the first parameter as tm, and that's the value. This is the first value, which happens to be of type list tma. That's my bind method. And the second parameter is this function. Let's call this function f. Okay. And the implementation to this method, is going to be right here. I'm just going to provide the implementation in just a second. But before you do that, let's just think about this. So if I have my first parameter, here, tm, that happens to be some value of type list tma, and then I have a function f. That happens to have the following type here. That's a type signature for my function f. The entire thing over here, the implementation over here, is going to give me back some value of type list t of mb. Now let's think about this. What is some value that happens to have a type of list t mb? Again, if I look at my type definition over here, I can see that if I were to invoke the value constructor list t, but if I were to provide in the appropriate value for the first field, I will then have some kind of a value which would have a type, in this case of list tma. So in that spirit, I'm just going to invoke my value constructor list t, and list t, that's my value constructor, and I'm not going to provide the other implementation piece over here. But again, let's just keep the big picture in mind here. What I really need to do is I need to provide in some value. As long as I can provide in some value of type mb, okay, if I can provide that some value of the following type there, I would in a sense have completed the actual implementation of this value constructor. I mean, just making sure that if my types match up, then I'm in essence all done. All my types correctly match up, even the type signature for the bind method. So what I really need to do right now is that need to fill in this green box here. Okay, if I'm thinking from this green box here, and if I just get my curly braces correctly lined up here, So this curly braces is matches with that curly braces here. And inside here, in this green box, there's some value that's going to have a type of this monadic expression of M of a list of B, and that's my value constructor. Okay, so let's think about how am I going to get this green box filled up here. Okay, so let me just erase these things out again. Okay, and now let's think about how am I going to provide the implementation in that green box. Okay, so first thing what I have here is this value tm. I have this value tm which happens to be of this type list tma. If I invoke run list t, this in essence is going to unwrap. It's going to start unwrapping. It's going to start unwrapping the value of type list tma into this monadic value of m of list of a. So what I mean is if I call run list t on tm, okay, what does run list do? Run list t takes in some value of type list tma and it's going to give me back some value which is this monadic value. This entire thing in pink here, this entire thing in pink is going to be the output. So I'm just calling my method run list t and I'm providing in that value tm, and I know that tm is some value of the type list tma. Okay, so these match up correctly, the type of these arguments match up correctly, and in return what I'm going to get back is this monadic expression. Now on this monadic expression, this is really super important here. On this entire monadic expression, right, and I'm saying this monadic expression is in this context of this emia. Okay, in this monadic expression, if I use maybe I can just use the do keyword here, because this entire piece is a monadic value. So I can say, I forgot my do keyword here, so let's just say do, and what I'm going to say at this point is I'm just going to say let's have as. So let me just again use my colors consistently. So I'm basically just having my this entire do block here, because this entire piece is a monadic expression. And what I'm going to do is I'm going to have as, and I'm just going to unwrap. I'm just going to tear apart. I'm just going to tear apart the actual monad or I'm just going to tear apart the actual context from the value. Okay. So what this does is this entire piece over here, has a type. It has a type of m of a. And by separating the context out, what I have now is this as. This as over here has a type where it's a list of a. Okay, so I'm just trying to show you. Maybe I should just use a different color here so that we don't confuse the actual code with the types there. So this piece in yellow has a type of m of a. That's the monadic expression there. And this piece over here as is where the actual monad m has been taken off. It's been taken off, and I'm just getting the actual value that was wrapped in that monad m. Okay, so far let's just think about this again. I have something now which is as, which has a type which is basically a list of a's. But again, the method that I have with me, at my disposal here, this method f here, takes in something as an input argument of type A. It doesn't take in something of type of a list of A. So I still need to think about something. I cannot just say f on as and hope that this method f, when invoked on the argument as, is going to give him back list mb. That isn't going to work here. So if I think about the map method, the typical map method has the following signature. So if I look at the map method, the signature of the map method is it takes in as an input a function that goes from a to b, and it takes in a second argument here, which is a list of a's, and I get back as an output a list of b's. Okay. Now maybe something like this could be a little bit useful, or at least I can start thinking about using maybe a variant of the map method. But let's just think about this. if I were to use a map method as it is, the way it is currently defined here, okay, what I really have here is I have this list of A's with me. Okay, I have the list of A's with me, which is right there, the list of A's. Okay, and if I take this map and I pass in the function f, which is given to me, this function f there, okay, and I pass in my list of A's, which is in this case as. So as I start feeding in every single A's into my function f here, this function f is going to give me back something of type list m of b. Okay, and this, what I really need here as per the map method, is something which happens to be of type b, but what I get back over here is something list mb, some values of type list mb. Now maybe I could start thinking of a function composition, and by thinking about function composition, what I can do is if I have this method, if I have this method f here that goes from, I'm just rewriting the signature for f here, that goes from a to list list m of b, and then I have a function over here, run list t. I have a function run list t that goes from list t m of b to m of b. I'm just rewriting this type signature for run list t over there. And if I do a function composition between the two, that is, if I pass in a value a over here, some value of type a, and I get back some value of type m of b, this is as good as just saying run list t and doing a function composition with f here. So in this case, I can just rewrite this map m f of as map run list t function composition with f, and then pass in my as. Again, what's going to happen here is this entire the entire output from here, is going to be some value of type this. If I rewrite the function signature for this method here, it is a function that takes a and gives you back some value of type m of b, right? And the map method is something that takes in a function that goes from a to b. But what I'm providing here is a function that goes from a to a monadic value. So it's obvious that I did make some progress. Where maybe I should actually be using the map method. I could be using the map method in some sense over here. But what I still don't have is the lining up of my types here. Map method explicitly wants something that is a function that goes from a to b. There's no monad involved at this point here. But what I have here is a function that goes from a to a monadic value of m of b. Now, if you were to use Google, and if you were to put the following type signature on Google to see if there's actually a method that does this, there is a method which is mapm, and you may have already guessed here that mapm is exactly what we need here. So let's just get this mapm, maybe just paste it right there, and let's see what mapm actually does here. So mapm is this method where it specifically puts a really strong constraint that m is something that must be a monad. And I have a function over here that's the first argument that goes from a to m of b, and that's exactly what I have here. I have this function that goes from a to this monadic value. And then as a second argument, all I need is this list of A's here. And I've already got my list of A's right at that point. Okay, so let's make use of this. If I were to make use of this, what I get back in return are these monadic values, where I'm going to get m of my list of B's here. Okay, so the only difference is that I have this function that goes from a to a monadic value, but my b's are already wrapped in a list here. So if I can just think about this, what I have here is let me just rewrite what I have at this point. Is this I have my a's that goes from m of b's, and I have my list of a's, and in return, if I were to just invoke map m as it is, I'm going to get back m of list of B's. Okay, assuming this is the function that I'm going to feed in. If this is a function I'm going to feed in my map m, this is the final output that I'm going to get back here. This is the final output I'm going to get back here. Okay, so what does this mean here? What does this actually mean here? So let's continue with this implementation, and I'm going to say at this point map m. I'm going to pass in I'm going to pass in this function composition of run list t dot f. So I just need some space here. So let me just rewrite this a little bit more clear here. So I'm just going to say uh, run list t function composition with f. This is fed as my first argument into map m, and my second argument over here is my as. Okay, is this parameter as here. And if I were to because this entire piece over here gives you back a monadic value which has the following type. The following type is this entire piece gives you some value of type m of list of B's. Okay, if this is the actual type here, and because this is a monadic value, I can separate the monad. I can separate this monad m out. I can tear it apart. I can separate the m out by getting all my list of B's. Okay, so this BSS is going to be something of type of list of B's. Okay, remember I've just separated the monad out from this. After having separated the monad out from here, what I still need to do is, because I'm trying to create a value, remember the very big picture here was I'm trying to create a value. I'm trying to create a value using this value constructor list t, which in turn is going to give me a value of list t of m of a, right? What I have so far is this BSS, which is of list of B's. All I need to do at this point is just concatenate these B's out. I just need to concatenate these B's out so I can just get a list of B's, right? So if I call concat the inbuilt Haskell function on my BSS, right? The type of this entire thing is just a list of B's. Okay, so what I have so far is I've got this part done. I've got my list of B's right there. This piece is done here. Excuse me. So if you remember again, I'm trying to create a value of list t of m of b. I've already got my list of B's here, but all I need is now this monad m there. If I call return, okay, this is the implementation of the return in whatever this monad m is. Whatever this monad m is, this could be a list monad, this could be a maybe monad, it could be a state monad, it could be any monad, but I'm just invoking the return implementation in that instance. And once I invoke return on this entire thing here, this is going to give me back this entire piece over here. This entire piece here is going to give me back some value of type m of b. Okay, and finally I can just close my parentheses here. I can just close these parentheses here. And now I've got the actual implementation to my bind method or list transformer. Okay, so this entire piece over here, okay, is the implementation. This entire piece in the green box is the implementation to the bind method in my list transformer. In the next video, we're just going to wrap up. We're going to have a really short video. We're just going to wrap up by making my list t an instance of the monad transformer type class.